Okay. The first two or three things I missed the recording. I hope you can recall it. I'll be pasting the queries. But the set operator, I'm just repeating once more time. The set theory, to avail this kind of operation, we need to create more than one data sets. Okay. We already created two data sets, employee underscore BPO, employee underscore IT. Let me just quickly show you the records inside employee BPO. Okay, I missed from. Okay, so we have only these two records for employee ID 114 and 116. They are BPO. And let me also check employee ID. Okay, in employee ID, there are three different records available which are having only IT related information. Let me do a union operation in between those two data set. How to do that? Select star from employee ID. I'm just doing the select star from the first table. In between, put union all or union, then put the second table. Okay, so you can see this is nothing but the first table's output is this, the first of three records, and from the second table we are getting these two records. So the entire data sets are merging in this manner. Okay, we can put another union over here. Putting another data sets, it will also getting merged at the below. So this way we can do union operation. Okay, now one more important thing. So while doing this kind of union operation, union, all this kind of operation, or any kind of set theory operation over here in SQL, the first criteria should be the two tables must be having same number of columns. Okay. If we are having different number of columns, then the union all will not be possible. Union all, those kind of stuffs will not be possible. It will be throwing error. Okay. Suppose we have a student table. Let me do union between student and employee BPO. Let me just show you. In student table, we are having only three columns over here. If we just go ahead with student union with employee BPO, it's showing an error. You can see the used select statements have different number of columns. Okay, so these tables have different number of columns. This table is having different number of columns. So the union all operations are failing. Okay, so the first criteria we should be having different number. We should not be having different number of columns. Otherwise, it will be throwing error. But suppose we have same number of columns, but the columns are not in same order. Maybe in employee ID, the first column is not uh, employee ID. In this table, the first column is a different column. In this table, there is another column as a first column over here. If we do the union all operation or union operation, the output should be generated. But it's not a good output because the things are merging inappropriately. It will not be efficient. We should not be using that kind of data set as output in our future reference. So their execution should be fine. There will be output. There will be no error. But the output, it should not be inappropriate. It should not be good. Okay. So just remember while doing this kind of set theory operation, we should be having same number of columns, as well as the columns should be in sync. Okay, in both of the data sets. In employee IT or employee BPO, we can see all the columns are in sync as per the order. So that is why there will be no issue. Okay, it's clear for everyone.
How about the data types? So, like when we are performing a set operation like union between two tables, like the data types of the respective columns should also be in match, right?
Data types should be matched, but I checked maybe in few cases. If we do not put data types in matched in sync, then they can also do, I mean, there will be no error actually, but they will be merging these things. Maybe there is varchar in one of the data type and in the same number, I mean, same columns in another data sets, it's integer. So at the resultant output, they will be converting it to varchar. Okay. I think I checked this thing in last session. The similar kind of questions was arised. So if there is any data type mismatch, it will merge it, and the resultant output will be having. Suppose varchar is there, so varchar should be getting the priority, and the resultant data set should be creating as varchar. Okay. But the same thing, it should be inappropriate. It is not a good practice. But we should be receiving a data output. There will be, I mean, no error should be thrown at that time. Okay.
Mm-hmm. Okay.
Just have a, I mean, you can also try. I think I tried it in the last session. That's why I can recall it. So the same thing I'll be repeating once more time. Error will be thrown only the number of columns are not matching. But if we want to go ahead with this kind of operation, we must have to think the columns should be in proper order. Employee and employee BPO, the data type should be matched. Uh, yeah, those are the main criteria. Otherwise, we are doing this kind of thing for some purpose. We can get what is the purpose. I'll be giving some exercise over there. You can see what can be the purpose, why we should be using the union. Okay. The output can be stored somewhere else, or that output can be required in other queries. Okay. If that time there is mismatches in data type, it that time there is some issues. Maybe the columns are not in sync. The union operation has been completed with employee ID and employee date of birth. Suppose in employee table, the first column is employee ID. In employee BPO, the first column is date of birth. So the union all operations should be completed fine, but the data should be inconsistent. The first 5 rows are having employee ID. The last 5 rows are having employee date of birth, which is a very bad data. Okay, so that is why while doing the set theory, we just need to check whether the columns are in order. Okay, those are synced properly. Okay, so this is very important concept when we'll be learning the similar kind of stuffs in Python. In Python, we'll be creating data frames. We can do this kind of union. The operation's name is not union. It's a bit different. It's append, just like this. So you can see there should be some changes. The concept should be a bit different at that time. But as of now, just remember these things for SQL. Okay. Now one more important thing. I'm doing a union between employee. Employee is the main table, and employee BPO. It's only the BPO related information. I'm doing a union operation over here. Not union all. It's only union. Okay. There is another operation called union all. I'll be going to this topic later. Let me just quickly print the data. So you can see all the data from employee tables are printed over here. Okay. Employee BPO's data set, it's a subset of this employee. You can see just, I mean, the BPO related informations are also here. So The two records in employee BPO are nothing but a subset of employee. So those are not printed separately if we are going ahead with union operation. The same thing, I'm just putting a union all in between them. Just I'm putting all keyword. I'm running the same query again. Let's see the difference. So till this row, starting from the first row to till this row, this is coming from employee table. The next two row for employee ID 114 and 116 are coming from employee BPO table. Okay, those are nothing but this row and this row. Those are coming again over here. Okay, so the main difference between union all and in union, while doing union all, it will not check for duplicates. It will be just merging the two data sets vertically one by one. But while doing union, it's very, very good operation. It will be checking for duplicates. If there is any duplication entry during this union operation, it will remove that thing. It will only maintain the distinct records during union operation. Okay, maybe there are some duplicate records in first data set. It will not handle that thing, but it will handle during union operation. If any other data from any other data sets, it's getting duplicated during doing the union operation, it will remove these things. It will only maintain the distinct. Okay, the concept is clear. Maybe the difference can come in interview. So what is the difference between union and union all? You just need to specify that thing. Union all, it will not remove duplicates while merging the two different data sets vertically. But while doing the union operation, it will remove the duplicates while doing the union operation. Okay. Let's go ahead with intersect. What is intersect? It's nothing but intersection. Okay. Okay. So I'm doing an intersection operation between employee and employee BPO. It will be retrieving the common columns. Just like in set theory, we learned intersections in Venn diagram or just like this. The common portion is the intersection. Over here, the same thing is this. Let's start from employee. Let's start from employee BPO. Okay, we are doing the intersection operation. It's nothing but this kind of intersection. Okay, so suppose we do not have, mutually exclusive data sets. Okay, let me just put employee IT over here. So there is no common records between employee IT and employee BPO. If we just run this thing, it will be returning 0 row. No rows are present because there is no column records, no matching records between employee IT and employee BPO. That is why there is 0 records. It's clear for everyone? Any doubts so far? It's fine.
What are the complex queries we use in the real-time scenarios?
It's Tarun, correct?
Yes, yes.
Tarun, can you please repeat our complex
I mean,
queries?
like complex queries. I mean, the regular what we use in our.
Yeah, complex query, we will be just going ahead with these things. Currently, we are learning all those DQL stuffs. When everything we can learn all those stuffs, we'll be trying to merge. Maybe in a same query, we are having aggregation. In the same query, we are having subquery, as well as the same query is having joins. Okay. Suppose when we are creating some views, database views, over there are maybe there are 10, 20 tables we are joining. Okay. And we are getting only a single data set. But we are putting some join, we are putting some filter operation, we are doing some aggregations, we are putting some Windows functions. So those kind of things, when we'll be performing in the same query, that can be complex. Okay. But as of now, we just need to
Okay.
know all those basic stuffs for going ahead with those
Yes.
complex steps. So I'm just covering
Okay.
one by one.
Okay. Thank you.
So maybe when we'll be putting those exercise, you can find some of the complexities over there. Okay, yeah. Any other questions? Maybe Sri Charan, you were telling something.
Oh, it's nothing. It's clear.
Okay, it's
The
fine.
same doubt I got about trans.
Sri Charan, is this your, I mean, what is your first name actually? If I just call you
Yeah, it's Sri Charan.
Sri Charan, it's fine. Okay.
This is not my first class actually. I have attended three classes. The first three classes. Just got a break. I'm
Your
continuing from
voice is echoing a bit, not getting it properly.
now. Is it good now?
Yeah, it's a bit better. Yeah, you can tell.
This is not my first class actually. I have attended first three classes and I have got a break and I'm continuing from now.
Okay, okay. So
Uh,
I think you already have the data experience, correct?
yeah, a bit of experience. Yeah.
Okay, I think then there'll be no issues. So you have
Yes, yes, yes.
starting with the
Yeah.
very basic stuffs, the operations one by one. So when we can cover all those things, I'll be giving some exercises. So but there we can have those recaps as well as some complexities, some intermediate levels of queries should be also there. You can go through those things one by one, then all of our doubts should be cleared.
Yeah, sure. Yeah.
Okay, okay, yeah. Okay, the next topic, it's joins. This is very, very important. Set. I hope there is no doubt for set theory. It's fine for everyone. Now it's join. What is join and all? I'll be okay. Let me give some introductory things on top of joins because join is very, very important. Maybe for the first 1 or 2 days, I have shown you some pictorial diagram to understand primary key and foreign key relationships between multiple tables there. So that time I mentioned that in two particular tables we are having a common columns by which we can set up a join, and we can join the two tables and we can retrieve one, I mean some columns from other table to another table. I have some examples in Excel. Let me just open these things. Let's understand these things. If it's clear, then we can go ahead with syntax in SQL over there. Okay. Let me open this one. Okay. As of now, it's simplest kind of join we'll be learning one by one. As of now, I'm not going ahead with primary key and foreign key once more time. Let's just think about that two of the data sets are having different, I mean, two of the data sets are having one common column, just like we have two data sets. The first data set is having employee ID and employee age information, and the second data set is having employee ID and their designation. Okay. So by checking this data set, I cannot confirm the particular employee's designation, as well as from this data set, I cannot confirm what is the age of this particular employee ID. But those are having, I mean, those particular data sets are from the same organization. In a particular organization, we always know that the employee ID cannot be different from this data set and this data set. But if we just look both of the data set, the single glance, then we can quickly confirm that this employee ID is having the designation data scientist. How we can confirm this? We are joining in our mind itself because we have the common column available in both of the data set. Okay. So this is the concept of join actually. And why we request joins? If we want to retrieve some columns, maybe one column or more than one columns from one data set, from this data set, to this data set. I am just trying to have a tally. We are merging it horizontally actually. So in the resultant data set, I want to check employee ID from this table, employee age from this table, and only designation from this table. If I want to check in this manner, this is called join. In join, we are creating a totally separate data set over here as output. Okay, and we are getting all three columns at a single data set, and this is called join. This common key are helping us to determine the join. Okay, now there are multiple kind of joins are there. One of the joins are called inner join, and another type of join is called outer join. Inner join is only the common. In the employee ID is the common column over here. Now find what are the common records. You can see in employee ID 1, 2 is common with 1, 2 over here. 3 is a different one. 3 is present over here, but 3 is not present. Over here, 4 is present, but 4 is not present over here. Okay. So during performing any inner join operation, it will be checking only the common data. That is only 1, 2. So inner join will be printing the data related to 1 and 2 only. Okay. This is called inner join. What is outer join? Outer join can be segregated into three things. First is left outer, second is right outer, third is full outer. Let me just hide these rows. Okay, we learned what is inner join. We learned what is inner join. Now we'll be learning the outer join. In outer join, the first thing should be coming left outer join. Okay, inner join, during inner join calculation, we are taking the matching only. Matching means 1, 2 is matched with these things. That is why we only took the matched one. For outer join, it will not be checking the matched one. For left outer join, we need to consider one of the table as the left table, one of the table should be right table. As of now, let's think this is our left table, this table is our right table. So during doing the left join, we will be thinking the left table should be our main table. We will be taking all the data elements of the common row, column, common column is employee ID. So we are taking all the data from the left table. That is 1, 2, 3. Okay. We are taking all the information. We are having 45, 48, 50. Now I'm trying to have a match of 1, 2, 3 from this table to this table. We can find there is match data scientist and senior manager. Those are from 1 and 2. That is why they are able to successfully map these two information. But for this 3, there is no such informations from the second table. That is why they are not returning any value from this table to this table. It's simply a null value. So this is the output of a left join table. Okay, or we can also tell this left outer join. Both of the things are same. You can put left outer join. Similarly, for right outer join, it's a bit just opposite thing. There should be a right table. This is our right table. And this should be our standardized table for this time. Now this time we are taking employee ID from this table, not this table. I'm taking employee ID from this table, employee age from this table, and designation from this table. Okay, as this is our standard table, it's picking up all the employee IDs from here. Okay, employees, if we are putting these things, automatically designation should be All of the designation should be coming 1 to 4. 3 is not present here. Over here, 3 is present, but 4 is not present in employee ID. That is why during retrieving employee age, the employee ID 4, the employee ID 4, his age is not there. That is why it's returning null value. The difference is for the left outer join, it's considering left table as its standard table. So all the records should be populating from this table to this table. And for the right outer join, it will be taking right table as my standard table. So all the data from the common column should be appearing over here, and it will be taking this tables, and whatever is not present in left table, it will be passing as null value for that particular columns which are coming from the left table. Okay. And the full outer join means all the data set should be coming 1, 2, 3 as well as 4. It's coming from here. Actually, that is not the scenario over here. Let me just modify a bit. So I'll be taking left table employee ID. Just putting left. I'm just introducing both of the employee ID. This should be the actual output. Employee ID underscore right. Okay. So just give me some second. This thing will not be there. Null analysis. Okay. So while doing the full outer join, I'm taking employee ID from both of the data set just for my reference. Okay, let me just put in this way. Employee ID. Okay, let me put in this way. The concept should be much more clearer. Dot left. It means employee ID I'm taking from this table. If I just put employee ID, put right. From the right table, it's only taking 1 and 2. But this thing, it will be appearing null. Let me put in the same way. Left, right. From left table, it will be having null information for. There should be 1, 2, 4. Okay. So this should be the output. Okay. What we are learning? So left outer join, right outer join, it's fine. So now just check the difference. I'm just taking employee ID left. This is just the resultant data set. I cannot put the same naming convention. That is why I was taking employee ID only from this table in earlier example. Now I took two different columns for employee ID left. I'm just renaming it as employee ID left. Employee ID right, I'm just renaming this column from here to here. So during doing the left outer join, it will be picking up all the rows from here, but it will not taking the mismatched one. So it's not coming from this data set from there to there. For right join, we are picking up all the elements from right table. So what the things are matching, it's pulling from left table, but what's are not matching it, that those are passing as null. For full outer join, the matching records will be coming. That's fine. The mismatched record will also come. From the left table, it's pulling employee ID 3. While passing 3, the designation and employee right table are passing null information because for 3, employee ID 3, there is no such information over here. So that is why those values are null. Again, we are having some extra records in right table, that is 4. It's coming in this way, and there is no such reference with employee ID 4. That is why it's coming as null. Okay, so this is how the outer joins works. Left outer join, right outer join, full join. Any doubts so far? The concept should be clear for everyone because join is very important topic in SQL. If there is any issue or any stuck point, please tell me. Okay, I hope no issue. In the very next day, we will be performing the same kind of thing in our SQL query. We will be performing join by writing syntax there. But the concept should be clear over here. Otherwise, it should be very difficult to understand how the join works. Okay. There is also cross join. Let me just show you. I hide those columns. Yes, this is cross join. Cross join is nothing but the thing should be crossed. Okay. Suppose I'm crossing. There should not be any matching or mismatching. They will not be checking these stuffs. Suppose I'm joining these two data set. The data should be crossed. I mean, the data should be multiplied. For each of the combination of one record, this thing will be printed. Suppose for 145, employee ID 1 and employees 45, all of the three records should be printed. If I just print employee ID from the left table, employee age from the left table, and only designation from the right table, for each of the combination, all the three should be printed. It's just like a multiplication of 3 cross 3. Okay, there should be 9 records. The examples or the usage of this kind of cross join is very minimal, but we can find in some of the exercise. But as of now, the usage of these things in our business or any other criteria, it's very minimal. Just for information, you can take this reference what cross join is. Okay. During learning the same things in our SQL, okay. In tomorrow's class, we'll be learning all those joins in our SQL syntaxes itself. Okay. As of now, just clear your concept what join is, how the join can be performed. Okay. In the very next day, we'll be going ahead with our hands-on part in join and by our SQL syntax itself. Okay, then that's all for today's class. Let's connect tomorrow with all those rest of the stuffs, top of charts. Thanks, everyone. Bye bye.
Thank you.
Thank you.
Yeah, thank you.